Let's talk about JavaScript. Right. So we can have executable content inside our pages. Right. We already saw that we can mix and match a couple of different technologies on the same page. Right. We saw that we can have definitely HTML, but we also can embed inside of HTML documents. We can embed CSS. It's a completely different language, right? That has its own syntax. That is used for its own purposes, and oftentimes CSS is referred to as a declarative language, right? You declare that these elements I want to transform, and I want to apply this transformation, a color transformation, a layout transformation, and you declare all these things, right? There's no programmatic way of doing it, whereas in JavaScript is a full-blown programming language that you can also embed in your websites. Whereas we were using the style tag to embed CSS in our HTML documents, here we use the script tag, right, to embed JavaScript executable inside of our code. Make sense? Right? And just like it's a good practice to move the CSS style sheets outside of the HTML document and link to it, right, using the link element. Right. Similarly, in the JavaScript, is a good practice not to have it embedded in your source code, in your HTML documents, but instead host it in a separate file and then link it and refer to it from within your page. Make sense? Right. So here's the simplest of JavaScript statements. Right. We have a script tag, and inside we have an alert. So the way the browser interprets this is that as it's parsing the content, it renders the content as it parses it. Right? There's no like I'm gonna go over it again, right? As I read it and as I convert it into a model, I go ahead and start rendering this, right? So whenever it gets to this script file, boom, it executes it. Right? It sees an alert, it pops up an alert saying "Hello world," and then it continues rendering the rest. Right? So that's very important, right? That's very important because you might have JavaScript here that might be referencing parts of the document that haven't yet been rendered, right? Because the whole point of JavaScript that we're going to be using for the rest of the semester is JavaScript manipulating the DOM, right? The document object model, right? The browser parses this DOM, renders the page, and what we're going to be using JavaScript for is to go back and programmatically look at that DOM, right? And move things around, change a couple things there, add new content dynamically, remove content, yes? Go fetch something from the database, from the server, and then come back with that data and then manipulate the page accordingly, yes? That's what we're going to be using JavaScript mostly in this class. So it's very important that we understand the order in which things happen, right? That you can't refer to things on the page in the document that haven't yet been rendered, right? That the browser hasn't yet parsed, okay? So we're going to be careful about that. Here are a couple other things. So alert pops up in an alert box. A console, you can write to the console. We already saw that, right? When we're looking at any document, we can say an inspect, and it pops up an inspector, and that we're going to be spending quite a bit of time inside of this inspector. We'll notice that one of the tabs there is a console. See that? This console is a great place to to look at. Where you can print out content, you can programmatically interact with the DOM that is currently loaded in. You can and as we go, we can see the parsed content and the way the browser how it has interpreted the document and converted it into this object model. We'll also see as we go. You can navigate through any source code that we might have downloaded from our servers or from the cloud. We can see any CSS style sheets, so we can peruse through there and look at the content. Notice that this has been minified, has removed all white spaces, so it's very hard to read. We have images, any other CSS or JavaScript or any other things that might have been loaded. Here's another JavaScript file, probably pretty big. It's taken a while to open it up. Anyway. So we're going to be spending quite a bit of time inside of this console. Also in the sources, you'll notice that on the right-hand side, we're going to have a debugger. We're going to be able to put breakpoints on our CSS and step through the CSS as it executes in the browser, right? Which is pretty cool. So you should really become proficient at being able to debug, right, as the behavior runs right here from the content. So you can write to the console right there. You can also write to the DOM, to the document, right, to the actual DOM object. Once the browser has parsed and rendered our content, once it's done, right, it gives us a reference to that object, to that model that has rendered on the screen, and then you can do whatever you want with it. One of the easiest things you could do is to write to the DOM, right? Meaning you can append content, to all the content that has downloaded from the web page, from the website, right? And it has already rendered and placed your hello world and welcome, yada yada yada, right? You can programmatically add to that content, right, by writing to it. You can write just plain text. You can write actual HTML, right? I want to add a new header. I can say H1 and then a brand new header, and that will update the DOM, and it will render on the screen of the page. We're never going to actually do that. That's very primitive. We're going to be using much more powerful ways of doing that. But nevertheless, it's the low level, the very low level mechanism of writing to an HTML document. You can also interact with the document that's already there, and you can retrieve content. It says, oh, look at that button that has rendered there. I can go grab that button, okay? And maybe I can change the inner label, right, dynamically, programmatically, right? So you can retrieve things from the content by an ID. So if you have set an ID on that element, you can go and grab it by ID. You says, well, return to me that element by ID. Go fetch it for me, and then you can apply all sorts of transformations. I want to convert the content of that element, whatever HTML is in there, just overwrite it, right, with my own content, right? So you can dynamically manipulate what is being rendered on the screen. So here's a really trivial example. You have an H1 element, and so let's play around with some of this. And so we're going to be spending some time here in the user table. So let's add some JavaScript here. Let's see. Down here we can say inside after the table we can add some script here. So script and let's see. We can say alert, obviously. Welcome to JavaScript. So that if we load the input field, not that one, the user admin, if we refresh, notice that it says welcome to JavaScript. Notice that it right, and then we have the DOM being rendered right here. Let's see. We have this user admin. We can grab it. If we give it an ID, and this is the title, right? We can grab it. We can say grab that element. So this is the var title. We can say document dot get element by ID, and it's called title. Right? We can say console log title. So if we run this and we look at the console, we say console. Notice that indeed it went, fetched it, and it printed it in the console. Yep, I have the H1. There it is, right? And it has user admin in there. See that, right? And once we have it, we can start manipulating it. We can say title.inner HTML and and we can change it to be something else. Welcome. So notice that indeed of saying user admin, I have manipulated, right, and programmatically changed the inner content. Yes? Again, this is very, very low level. You would never actually do this, right? Instead, we're going to be using much more powerful libraries, right, that create an abstraction layer so that we don't have to dirty our hands with so much low level stuff. Okay. Nevertheless, I wanted to just give you a knowledge that this low-level library does exist, right? Of which these other more sophisticated libraries are built on top of all these details underneath. All right, so let's see. Let me go back. Hello, so we got the elements. We can change the style, right? We can change the color. We can change the font size, right? So every element has a style object, which we can dynamically change the color, the font size, the background color. We can change it from inline to block. We can also dynamically write dates. So here we can grab the today's date, and then we can write. Here we can say document, write a brand new H2 and grab from today's date, right? I want to grab the month. Right, so let's take a look at that, what that renders. So it would be at the bottom. There it is. So this is the 4th month. It's 0 based, so 4 is May, and so we can do all sorts of content. We can write the entire object, the entire date. There it is. There's today's date. Fully rendered, right? And you can format it any which way you want, right? All right, let's see. Let me just work with these two. All right, let's see what else. You can render arrays. You can iterate over the arrays here. So the full-blown programming language, right? You can iterate. You can have functions. You can pass in, parameters around. Here we're just iterating over an array, computing the average. Here we are dynamically rendering a UL. A UL is an unordered list, right? So for instance, if we create an array of scores, if we render an array of scores, we can then iterate over them and write a dynamic unordered list. Oops, copy. So write open an unordered list. As we iterate over the scores, we're going to write each one of the scores and then close each one of the line items and then close the unordered list. Right. So if we render that, notice that at the bottom, indeed, we have each one of those scores rendered dynamically. Yes? Okay. Again, this is way too low level to spend too much time on this. Let's see, any other? Hello, simple math, reading, adding, so a very simple addition calculator. Again, way too low level. Add plus. Okay, the only thing that I do want to point out is this data format, okay, which we're going to be using all throughout the semester, right? This data format is called the Json data format, JavaScript object notation. All right. So in JavaScript, it's very easy to create an object. Here we're creating an object literal, right? Just like a string might have a literal where you put quotations and you actually write out the string. Yes. Same thing here. JSON is here's a literal object notation where we open up the curly bracket and then we have various name value pairs. Name value, name value, name value. Yes. Separated by commas and the name value separated by a colon. Right, so this notation is called JSON. We're going to be using this all throughout the semester quite a bit. Most of this is going to be data that we're going to go fetch from the server. And then you can use the dot notation, right, to be able to navigate through the various contents of an object, very much like you would in Java. Yes? So here's an example of grabbing some field, right, and changing its inner HTML, right, changing it to the value of how many rooms a house have, how many baths, right, how many square feet. Use a strict. The browser is very lenient when you write code, right? For instance, allowing you to write global variables, things like that, and so it's not going to complain. Right? It's not going to say anything, but that's a good practice is to let the browser know to be stricter. So don't let me do stupid things, okay? Like global variables. Throw exceptions or complain if you see something that you don't like, okay? So one way to do that is to include this string anywhere in your JavaScript file, right? And when the browser gets to this and parses it, it says, "Oh, okay, all right, I won't be such a pushover." right? So when it sees this, the browser is going to start complaining, right? And so if it sees you declare a global variable, right, it's going to complain, it's going to throw exceptions and whatnot, and so that it'll let us know. Yes.
Where does it do the complaint?
In the console. Yeah. Yeah. Yes.
Does it stay true for all JavaScript
Yep.
browsers or after?
Yes. Exactly. Yep. Let's see. IIFE, or immediately invoked function expressions, right? The current version of JavaScript the ones that are mostly supported by most browsers, doesn't support modules, doesn't support like namespaces, like something that we take for granted in Java and many other modern programming languages. Is that you can namespace, right? You can create your own packages, right? Your own classes, and then the variables that you declare in there belong to that namespace, right? They don't litter the global namespace. Make sense, right? That's not the case in JavaScript, right? If you declare a function, a variable, right, everybody can see it, right? So it's very common that, especially because just like in Java, you might do imports and whatnot. When you do an import, right, the import usually is very well namespaced. You have a package name. Usually that package name is a unique package name, yes, that might belong to some other company, and that it has the full-blown name of that class that you're importing, yes. And so even if you have two variables or two functions that are called the same, there's never collision because they belong to their own packages, yes. There's no such thing in JavaScript, right? So whenever you do a script and you load some other library, right, you could run into a case where one library declares a function, and then another library later on declares the same exact function, right? And it's going to overwrite the old function, right? Or you might do it, right? You might create your own function and inadvertently just overwrite somebody else's function. Make sense? So to deal with this, again, in the current version, the newer versions, we don't have this issue. But the one that's mostly used by most browsers, we still have that problem, namespacing. So the only thing that is guaranteed to be self-contained, a self-contained namespace, right? The only thing that's guaranteed is inside of a function. Inside of a function, anything you declare inside of a function is indeed namespaced within that function. Yes? It's a local variable. It's a local function. It's not overriding anybody. And once the function finishes, all that goes away. Yes? Right? So using that mechanism, we have the community has come up with somewhat of a hack to use that technique of functions to declare namespaces. Yes? So today it's a good practice that whatever code you're going to write, you're going to write it inside of a function. All your code lives inside of a function. Right? That means that whatever you have in here, it's not going to litter the namespace. It's not going to override any other function. Right? It only lives inside of this function. Make sense? Right? The other thing is that once you declare this function and you have all your code in here, well, somebody has to call it, right? Because somebody has to, get your code going and running. Yes? So one way to do that is to give the function a name, and then call that name, that function. But that kind of defeats the purpose, right? Of calling the function, giving it a name, because that function could override somebody else's function. Make sense? Right? So instead, we use an anonymous function. Right? It has no name. So how do we call it? How do we invoke it? Well, we can put a parenthesis around it and then put the invoke operator on the right-hand side. Right? This operator says, ooh, you want to execute something. Right? Well, whatever's on the left-hand side should be a function. Indeed, it is. Right? So whatever's there, I'm going to call it. I'm going to invoke it. And indeed, it gets invoked. Make sense? Right? So any code that you might have, like there's all this code, right? The good practice is to put this inside of a function. Right? Okay, so all this code would live inside of this function. See that? Now I am no longer overriding any functions, any variables that might have already been declared. right? It's all it's self-contained inside of this function. If I run it, it behaves identical to what I had originally. Right? It runs identical to what I had before. Make sense? Right? So this became very, very popular within the community, the JavaScript community. It's becoming less and less important now that we have React and ES6 and we have a TypeScript and all these new languages, right? That allow us to do imports and have packages and have all sorts of things. Yes? Nevertheless, it's something that's still around and you should be aware of. Okay? Any questions? All right. Let's see, what else we have? Example, to-do list. All right, this is a to-do list using JavaScript. I'm going to leave that. I'm going to instead jump to jQuery.